Hello and welcome everyone. I am Ravi and today we'll be going through a set of examples for using permutations to do counting better. So in this example, um, let's go through a question wherein Harry is given 5 books and what we need to figure out is how many ways can he distribute 3 books and place them on a table. In how many different permutations can he place any 3 of those 5 books on a given table. So let me write down the 5 different books that Harry has, have a demarcation for them. And let's assume that you're given, to solve this problem, you're given 3 different buckets. So these are books and the blue markers indicate buckets. So this is bucket 1, bucket 2 and bucket 3. So to solve this problem, let's assume and imagine that how many ways can any of the 5 books be placed in bucket 1? It's pretty simple. There would be 5 ways because you can choose any of the books to place in the bucket 1. But let's say you've chosen any of the books. Let's say you choose B2. How many ways are there to place a book in bucket 2? There would be 4 ways, right? Because B2 has already been chosen. So we write 4. And let's say you chose B4. So how many ways are there for the third bucket to be filled with a book? It's 3 because it could be either of B1, B3 or B5. So the total number of ways comes out to be 5 into 4 into 3. That comes out to be nearly 60. Now the question to us would be, how do we generalize? So let's imagine instead of 5 there were n books and instead of 3 there were k buckets. So in how many ways can you select k elements out of n and permute them? So this turns out to be, you can imagine that there are k buckets, and so how many ways would you arrange k elements or the n elements in k buckets? Considering one bucket contains one element, is you would try to fill the first bucket in n ways, you would try to fill the second bucket in n minus 2 ways, you would try to fill third bucket in n minus 3 ways, and so on and so forth. And so the last bucket would be filled in n minus k minus 1 ways. And this would amount to k buckets. Now, to remember this, you can imagine that this fraction f can also be written as n into n minus 1 into n minus 2 up till n minus k minus 1, and you can add another fraction n minus k up till 1 in both the numerator and the denominator to keep the value of the fraction just the same. So this would be plus 1, this should be plus 1, and this would be minus 1. Okay. And so this fraction can also be written as n factorial upon n minus k factorial. And there you have it. So to be able to arrange n distinct elements in k buckets, considering each bucket has only one element, the answer turns out to be n factorial by n minus k factorial. Thank you, and I hope you enjoyed this video. We'll continue permutations in the next video.